Welcome. I wanted to step through a homework problem to help you out as we have introduced now the standard normal distribution. So here's our problem. Below is a graph of a normal distribution with a mean mu of -5 and a standard deviation of 2. The shaded region represents the probability of obtaining a value from the distribution that is between -7 and -6. All right, so you can see over here, they've labeled the x-axis. So x is a value from this distribution. And we know that the mean determines the center of the graph. So there's our -5. And standard deviation determines spread. So spread from the mean. And I'll return to standard deviation in a bit as we move forward. So here is the idea. We would like to transform this graph into the standard normal distribution and then find out where that area would be on our new graph. So what we want to remember is standard normal is a special case of a normal distribution. So what makes standard normal special is that its mean, mu, is 0 and its standard deviation, sigma, is 1. So when I change this graph to standard normal, we'll see that the mean changes -5, it'll change to a 0. So we'll see 0 at the center. And the standard deviation, instead of 2, will go down to 1. So the 1 is smaller than 2, so there'll be less spread on the next graph from the mean. So let me just show you the graph. All right, so this will be our standard normal curve. And you'll see there now it's labeled Z. So we'll use Z-scores for our standard normal. And now the center is at 0. And the spread of the graph, so you'll see it's not so spread out from its mean. So this one had a larger standard deviation, so more spread from the mean. So this one is wider than the standard normal. So we're not always able to draw our pictures perfectly to scale, but that is essentially what they've been able to do for us here. And so I'm just going to say this one more time for emphasis. Normal distributions can have any mean and any standard deviation. But down here, standard normal is special. The mean is 0 and the standard deviation is 1. And we generally will use X to represent a value from a normal distribution. And then we change over to our Z-scores as we're talking about standard normal. So what we have to do is figure out where this area would be equivalently on this graph. So basically, we're going to take X values of -7 and -6 and change them into their Z-scores, and then we'll be able to graph. All right, so I'm just going to come back up to the top here. So let's start with -7. So if X is -7, and I need to know its Z-score, so the formula for the Z-score, Z is equal to X minus mu over sigma. So we'll take our -7 and subtract our mean, and our mean is -5. I'm not going to do any simplifying. I'm just going to directly substitute first. So -7 minus a -5 divided by standard deviation sigma, which is 2. All right, so let's just simplify here. So subtracting a -5 would be the same as adding. So -7 plus 5 divided by 2. And just keep in mind always order of operations. So we would do the numerator first, and you can always use your calculator for help here. So negative, negate the 7. So -7 plus 5 is -2 in our numerator. And then divide that by 2, and you will get -1. All right, so we'll graph that in a moment. But then let's switch over to our next X value, which is -6. And now I'll find its Z-score. So Z is X minus mu over sigma. So now we have -6 minus the -5 over 2. All right, so that'll be -6 plus 5 over 2, which is -1/2. And you could do it in decimal as well here, negative 0.5. All right, so aside from just wanting to show you how to step through a problem in general, I did want to focus on one where the mean is a negative number. So we generally won't see that throughout the semester. We don't usually have means that are negative as we do our applications, but it's certainly possible. And so this is just a homework problem from ALEKS that you may see one that looks similar. All right, so let's do it. Graph. All right, so now we know where this area is on this graph. So -1, so just draw your line there at -1, and then at -0.5, shade that area. So these are drawn to scale, but sometimes our eyes fool us a little bit, but the areas should be equal. So this area, if I were to paint this area, it would take the same amount of paint as if I painted that area. So you can kind of see here, because this graph is wider, it's also shorter. This graph is more narrow, so it's taller. So that region that's sort of wide, this region, it's not as wide, which is why it has to be taller. So those areas match. And that is how you will handle those problems. So you'll have your picture of your normal distribution, convert those guys into their equivalent z-scores, and then graph those and shade that region, and you will be done.